So first of all, we need to know what basically KVL means and what is the application of it. So KVL states that the sum of all voltage sources should be equal to sum of all voltage drops, which means that sum of all voltage sources minus sum of all the voltage drops should be equal to 0. Now this is the actual application of Kirchhoff's voltage law. Now let's see how to apply this theorem on a electrical circuit. So this was the circuit we needed to solve, and we need to find this output voltage. So how do we do that? So first thing, we need to assign these polarities for each component. As you can see, I have given that plus, minus, and then plus, minus for these two resistors, and the voltage sources already have these polarities for them. And now we have to keep them in that way throughout the whole process. So let's take a clockwise loop like this, and let's see what happens then. Okay, taking KVL loop 1 in the clockwise direction, we'll get an equation in this form, that minus 10 plus 4.7 kilo ohm, and then 0 plus 0.7 plus this resistor into I, and then minus 5. This is the equation, as you can see. Now how did I assign this minus, plus, 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 and then minus? So first of all, that we actually took that clockwise loop, and when we are actually traveling in this way, we are encountering the minus, then plus, then this plus, and then this plus, and then this minus. So that's how we actually wrote these polarities before each value. So if we solve this circuit, and if we simplify this portion, if we take this I as common, then R1 plus R2, and let's take the voltage sources at the right side of the equation and just solve it for this I, which is the current, and you will get the answer for that as I equals to 2.07 milliampere. So this is the current that has been flowing throughout this whole loop. Okay, now let's move on to the second one. Now we need to take a clockwise loop in here as well. So if we take that loop, what do we get? This is the equation we will be getting. Like this will be plus, because we are encountering the plus polarity first, and then minus IR2 here, as you can see, and then this plus V0, this one. So this whole thing should be equal to 0, as I have mentioned in the theorem of KVL. So just put the value of I, which we found earlier, which was supposed to be 2.07 milliampere, and the resistor 2, which is this one, 2.2 kilo ohm, and put it in here. And if we solve the equation, then you will get the output voltage equal to minus 0.45 volt. So that should be the answer for our question. So that was the basic thing about KVL. Just keep one thing in mind, that you need to keep these polarities on the elements or the passive elements like this throughout the whole process, and then you can take a counterclockwise or a clockwise loop. It's your wish. But and there's one more thing, that you need to take both loops in the same direction. If you're taking a clockwise loop in the mesh 1, then you have to take the same loop, which is the clockwise, in this mesh as well. Okay, so that's it. I hope you found this video helpful.